Hello, my name's Bill Somerville, and I'm going to make a short, not a short video, it'll be 15 minutes, trying to describe how 3D laser scanning, creating a point cloud, how software can be used to measure um, architectural shapes in a point cloud. And this video will show um, using Trimble RealWorks Viewer, which is free, and it will show measuring within the Scan Explorer option. This is a Tekla model, and I'm using it to say that this is a real site. Had some external stairs, concrete shapes, different things that needed to be measured. The general contractor in this case was responsible for taking the measurements. The general contractor measured it incorrectly, and this rather involved set of center handrails all had to be refabricated because the fabricator followed the directions provided. But this site also had a slope here. This was a slope that got the concrete stairs here, and then this was sloped, and so there was a little bit going on. There was also a number of stairs in the structure, and 3D laser scanning could have been used to help with any of that because none of it was that terribly easy. So I'll just minimize this. Okay, now we're in Scan Trimble RealWorks Scan Explorer, and we've got some shapes here that we can measure. And using the free tool. Now keep in mind that yes, you can measure within this free tool, but when you get a scan from a 3D laser scanning tool, um, you're not going to be able to take that point cloud from the laser scanner and use it with this free version. There's an intermediate software, which in this case is the full version of Trimble RealWorks, or it could be something else. Just another point here is that the images in this um, video here aren't as sharp as they normally would be, um, because this image was taken with a different make of scanner. Um, we didn't have the software at that time to take measurements from that scanner, so we exported them in an E57 format. We imported, or we opened up the E57 with Trimble RealWorks free viewer here, and so that's why the images aren't as clear and crisp as you would normally see. There's an outline. So these images were generated from some really nice images generated by another make of scanner, but it was imported E57 files that we're measuring from here. So time flies when you're taking these. So I'm just going to show you that we took some. This was the first scan, and so these doors were taken straight on, but we never had a straight on scan of this stair in this structure here. There's and that's the reason I wanted to take these measurements, to show you that you can get accurate measurements even if you're not measuring straight on. There was this 3 scans for this that included these stairs. There's this scan which was taking, you see where the black spot is, that's where the scanner was sitting. So the scanner was sitting in the doorway, and you can see that we don't have a really straight on example of any of this. And then we had the scanner sitting in the doorway. You can see the black spot, and so then we get some images from that. And so how can we take measurements from this using the free version of Trimble RealWorks? So time is just flying by, so we can get some measurements from here. Let's see what measurements we can get. Let's see if we can measure this bollard. Keep in mind that my interest with measuring is, of course, with structural steel. Measure from here up to there. This bollard should be 4 feet high above. .49 is measuring there. A little fuzzy, so we'll take that measurement again, and I'll just measure. If I can shift this around, I can't see this measurement. So that's the measurement we want to get next, is this measurement. So I'll go to a different scan. How about this one? This one might work. So to measure this distance here, we did measure it with a tape measure at the job site. It's 69 and an eighth inches high. So we'll go to the measuring tool, pick out a vertical measurement, carefully selecting here at the bottom. Keeping in mind that you don't want to use these measurements for building. They are the kind of measurements that you take just for a reference. It's quick to take measurements within Scan Explorer, measuring the visual item. Let's see where we at. Try to get close here. Pretty close. Okay, so it was 69 and an eighth with a tape measure, and it's 69 and a 16th there. Keeping in mind that the scanners have an accuracy of 1/8 of an inch. And so that means 1/8 of an inch here, 1/8 of an inch there. So you can easily be out 1/4 of an inch. If you need to do precise measurements, you can go into the measuring the point-to-point distances, but that's a different tool. We're using Scan Explorer, which is measuring in the visual images. Let's take some measurements from some of these things. Let's see what we got here. This is not really clear. This distance here should have been 41 and 5/8. So how close can we come? What's it saying I'm doing wrong? Okay, taking that measurement. So I said it should be 41 and 5/8, and it's just a little bit under. We'll take that measurement again from another distance. Let's go to this scan where we're close. Okay, so I measured up some of these things in this area here with a tape measure. This doorway is 85 and a half inches high. Take a vertical measurement. I'll just measure from the foot. Don't get my little red dot. There it is. Up to here. So I said 85 and a half. That comes out to 85 and a quarter. Keeping in mind that, we can be out 1/8 of an inch at the bottom, 1/8 of an inch at the top. I said that we measured it at the job site. That door is 38 and 3/16 of an inch wide. So now I'll use the horizontal tool. Okay, just a little bit wider. Just as a point of interest, this sign is 13 and 5/8 inches wide. That's interesting. Oh, I went point to point. I need to make a horizontal measurements because it's create. So there you see that one is kind of unique. Let's measure this red fire extinguisher sign. It doesn't have a shape or an edge, and so I wanted to measure it to see how accurate that came out. It should be 18 inches high. So I'm on a vertical measurement. Try to get it square on as much as I can. There. Okay, it's 18 inches high, so that measurement worked out good, and it should be 4 inches wide. Just clear that up. Okay, it's measuring a little bit wider. Okay, so let's measure this, see what we can measure here. Okay, that's all in the blind spot, so I can't measure any of that. We'll measure the height of these pickets. They should be on the horizontal section 35.5, just looking for my notes here. Yeah, 35.5 inches high. So we'll just measure to here. Oh, it's because I was measuring horizontally. Okay, that's pretty good. So measuring fine measure, you know, you wouldn't want to build to this, but you can measurement. These first two pickets are 85 millimeters wide, so that would be 3.5 inches. Okay, it's pretty close. And so you see that you can measure. So let's measure this bollard again, just up to the edge here. Should be 48 inches high. Okay, still, you can see it's pretty close. Okay, let's go and measure some other things here. We'll go to a different scan. Not that one. What's the scan gonna do? Looking for these joists. Okay, you can't measure those joists that easily because they're covered with that cementitious spray, so it's difficult to measure them. Try these joists to show, oh, I had it there. These joists should be 62 inches apart. I'll just see if I can get them in the so not everything, so we'll just measure from here, measuring horizontal. So there it says they're 4 feet, maybe so yes, I can see I'm wrong. It's these joists over here that are 62 inches apart. Okay, I went back in the model and rechecked, and it's these joists are 50 some inches apart. These ones are 62, so it measured that correctly. Okay, back to the point cloud again, and I'm just going to take one measurement as I'm just about out of time. How wide is this pipe? Oh, didn't do it. Oh, what's the diameter of that pipe? Pretty close, okay. Call me at 1-866-742-4299 if you have any questions. I'm going to end the video. It's at 15 minutes now. That's an example of measuring within point clouds.